Hi everyone, this is the video that goes over the sum and difference of cubes. This is a part of the notes that not everybody got to finish, so I wanted to make sure to post this video today so that you could be a little bit more familiar with it before tomorrow. So the sum and difference of cubes is exactly what it sounds like. It's so plus, or the difference, subtraction, between two terms that are, meaning you can cube root them. An example of a square root might be 2, because I can break this up into two twos. However, the cube root means you are trying to break it up into 3 things. So another 2 is 8. I can go on to talk about variables with this. So the steps for factoring out with the sum of cubes or the difference of cubes starts how all of the other factoring processes start, which is factoring out the GCF. I'm going to skip step 2 and come back to it. The way that the sum of cubes or difference of cubes is that the coefficients, the number exponents need to, and the reason they need to be divisible by 3 is because when you cube root x cubed, what you're really doing is, which is 1, x to the power of 1. The cube root of x to the power of 6, really doing x divided by 3, which is, if you really want to get fancy, we x to the power of 27, 27 of 9. Need to be at least divisible by 3. That way they can be cubed. Are going to look like a binomial and trinomial. So we have a binomial here and a trinomial here, a binomial here and a trinomial here. I want you to pause the video and take a look at the sum of cubes and the difference of cubes, those formulas. Notice what's the same about them. So pause the video and what's different about formulas. So for things, I notice that the first factor is either a plus a minus b. So they both have an a and a b, but the difference is that they're different signs. The next factor, the trinomial, I notice has an a squared, an a times b, and a b squared. But the thing that's different, again, is that first sign that connects the first two terms. So things that are the same are the terms, and things that are different are their signs. So I'm going to factor into a binomial and a trinomial. And the way I'm going to do that is of each term, meaning I'm going to divide exponents by 3 of the sum are different. I don't know. So at the I have 1,000, the perfect cube. So example, I know I have a sum. Fixed squares. I don't have a sum of squares, difference of squares. So I'm going to try and cube root these. So 8 squared, a times b, and b squared for my trinomial. So is x squared. And I'm going to substitute all of those values in the formula. So in my sum of cubes formula, I have So x. And next term, I have a squared plus b squared. Now something left blank in our notes, SOAP. And SOAP is to help remember the signs. So for the cubes and the difference of cubes, F, same. So the first sign is what we had in the problem. The O stands. So the next sign is the opposite. And then the last sign is always a plus sign and a plus sign. If you remember the order of these terms and you can remember these formulas. So for example 2, I have noticed that I cannot square root x cubed. Cube that. A x cubed. The cube 3, and the cube root of x cubed is 10. So b is a squared plus 4 times this have the sign, the opposite sign second, 2 minus 3x squared. So 4 and for our third question, notice that there is pretty large and a lot of variables and exponents. I noticed that they both have at least y cubed. Each one is 2y cubed times to the power of 6. Some can be cubed, not square rooted. So is 5. Six divided by 3. So I have 5x. I have square. Is 10xy squared, so I multiplied these two together. And out squared is 4. That comes from here and multiplying it by itself. So, yeah. Oops. Need the same. And a plus b order a squared is 20 squared times is 10x b squared 4. And I am know that you're going to bit. I was trying to into about 10 minutes, so the video to watch tonight. Remember, keys for the reviews are posted in Schoology already, so you can answers, and I'll see you tomorrow.